Welcome all my dear students. I am Bidhubhusan Nayak, the physics teacher. This is going to be your lecture 5 on units and dimensions. In the lecture 4, we studied what is the difference between dimensions and units, how dimensions are used to avoid confusion about multiplicity of units. So एक फिजिकल क्वांटिटीज को डिस्क्राइब करने के लिए ढेर सारे यूनिट्स होता है, लेकिन insofar as dimensions are concerned, it is one and only one for a physical quantity. That means for every physical quantity there may be a number of units possible, but it has only one dimension. And in the last, we discussed how to find out the dimensions of certain physical quantities like velocity, acceleration, force, either from units or from the formulae. So in this class, we'll discuss how to find out the dimensions of more physical quantities. Let's get started. But before starting, I must say one thing to all of you. Please do subscribe to this channel. There is a huge difference between a mere viewership and subscribers. Please do subscribe, like it and share it to your friends so that everyone would benefit from this effort of mine, especially so during this pandemic time. Let's get started. So in the last class, we found out the dimensions of certain physical quantities like velocity, acceleration, force, etc. So velocity dimensions we calculated is L(t to the power minus 1), or you can write it as m to the power 0, L to the power 1, t to the power minus 1. How it comes, if you have missed out my videos, then you may again watch it. Those who have missed out, please refer to that video. You will be able to understand how the dimension of velocity becomes L into t to the power minus 1. कैसे होता है ये देख सकते हो. And dimension of acceleration comes out to be L into t to the power minus 2, or better you can write m0 L to the power 1 t to the power minus 2. So certain dimensions you have got to remember. You have to memorize certain formulae of physical quantities as well as dimensions of certain 2 or 3 physical quantities like velocity, acceleration, etc. And dimensions of force you have to remember so that you can apply for finding out the dimensions of some more physical quantities. But dimensions can also be obtained from units. We know that dimensions can be obtained from formulae, but dimensions can also be obtained from units. But first of all, we have to remember units, then we have to find out dimensions. It will be a difficult task. So for that, we have to memorize certain formulas so that it will be easier for us to find out the dimensions. Dimension निकालने के लिए formulas memorize करना बहुत ही जरूरी होता है. So now we'll find out the dimension of certain quantities like momentum. Momentum, formula is equal to mass into velocity. Mass into velocity. Momentum's formula is mass into velocity. So for mass, the dimension is m, and for velocity, dimension is L into t to the power minus 1. So the dimension of momentum will be dimension of momentum. If you want to write, the dimension of momentum will be m.L.t to the power minus 1, or you can write like this. You can say the dimensions of momentum are 1, 1 and minus 1 in mass, length and time respectively. This is the way to express the dimension of momentum is 1, 1, 1, 1, minus 1 in terms of mass, length and time respectively. Similarly, we can find out the dimension of impulse. Impulse is force into time. Impulse is force into time. So for force dimension is m.L.t to the power minus 2 into, for time dimension is this much. So it becomes m.L.t to the power minus 1. This can be the dimensions of impulse. Similarly, one important thing is almost all the quantities in mechanics of physics, dimensions are expressed in terms of mass, length and time. No other fundamental quantities is required for the dimensions. So next is maybe angle. Angle is measured in SI system of units in terms of radian. Radian is the symbol of plane angle in SI system of units. But insofar as its dimensions are concerned, angle is equal, theta is equal to L upon R. Theta is equal to L upon R. तो L के लिए डायमेंशन होता है कैपिटल L. L is for length, so इसका डायमेंशन होता है कैपिटल L. R का होता है, R is radius is also measured in terms of length. Our radius is nothing but length, so that's why the dimension of R is L. So the dimension of angle becomes, this is a 1, L upon L is equal to 1. So the dimension of angle becomes m to the power 0, L to the power 0, T to the power 0. So you can conclude that angle is having a unit of radian, but it is dimensionless. Angle is dimensionless. So if somebody asks you, name two physical quantities having units but not having any dimension, that is plane angle and solid angle. Plane angle is used in terms of radian and solid angle is steradian. Both are having no dimensions. So angle is dimensionless. So you can write M0, L0, T0. Suppose you see work. Work is equal to force into displacement. Work is equal to force into displacement. Another physical quantity is work. Work is equal to force into displacement. So the dimension of force is m.L.t to the power minus 2. And the dimension of displacement is L. So that becomes, the dimensions of work becomes mL2 t to the power minus 2. So guys, please try to remember at least formulae of some physical quantities. Of course, you are going to study about these physical quantities in next chapters, but at this time you must remember certain formulae so that it will be easier for you to find out the dimensions. So work is force into displacement, and its dimensions is like this. So if you want to find out the dimension of energy, you see, energy is the capacity of doing work, and energy is having same unit, that is joule. Work and energy are two physical quantities with same units. Joule. Joule is the SI unit of energy, and joule is also a SI unit of work. So energy the dimension of energy will be same as dimension of work, that is mL2 T to the power minus 2. So this is the dimensions of energy and work are same. Suppose another physical quantity, that is pressure. Pressure, you know, that is equal to force upon area. Force upon area. That is dimensions of force being mLT to the power minus 2. Area, dimension of area is L square. L square. Because it is a product of two lengths. For example, area of a rectangle is length into breadth. That is a product of two lengths. So see, the dimension of pressure becomes, this is m L to the power minus 1 T to the power minus 2. This is the dimension of pressure. And another term, another physical quantity is called stress, is also having the same dimensions as the pressure. Stress is also equal to force or area. Stress is also equal to force upon area. That you have got to remember. Stress is also, stress and pressure are having same dimension, same mathematical formula. Then suppose strain is nothing but when a body is given some force, elastic body, if subjected to some force or tensions, then it gets elongated, and if it is compressed, then its length decreases. So strain is defined, as you will study in the later chapters. Strain is change in length divided by original length. Change in length divided by original length. So change in length dimension is L, original length dimension is L, L upon L is 1. So it is again dimensionless, but it is also unitless as well. For example, meter upon meter. So it is having no units and no dimensions. So these are certain quantities, and suppose another quantity is frequency. Frequency. Suppose a pendulum reciprocates in to and fro motion. So that once it goes from this to this and returns, that is a simple harmonic motion, and there is a term called time period. So frequency is defined as 1 upon time period. 1 upon time period. So its dimension will be second, its unit will be second inverse, and the dimension will be t to the power minus 1, because 1 upon time period, or you can say m0 L0 t to the power minus 1. So these are quantities in mechanics, but in the next lecture we will study how to find out dimensions of certain quantities related to electricity and heat and thermodynamics, how to find out that.